I'm recording this during a power cut, so I've got not enough light for me to show you my lovely face. So I am giving you a photograph that I'm very proud of. I took this picture of Jupiter some time ago. I'm not sure I could do it again, but I'm really quite proud of that. So I'm going to show it to you anyway. What we're going to do today is look at the lateral elbow pain again, and you may be getting sick of it by now, but I honestly don't care. If you can't do anything else at the end of this course, you'll be able to diagnose tennis elbow. But it does have the advantage of you knowing exactly what I'm talking about without worrying about what the actual diagnosis is. Although there may be a couple of surprises on this actual short video. It's because we have new tools at our command. We've looked at bias and error mitigation and what bias and error is, so we can include that in. And we're also going to talk a little bit about subtyping on this particular diagnosis. So this will come up more and more as we go along. But what we've got now that we didn't have before entirely is, first off, abductive reasoning. We can do hypothetic abduction and we can do differential diagnosis, both inclusive and exclusive differential diagnosis. And we can use DDX both for diagnosis and for bias correction. We've also got a focused and essential illness scripts, and just recently we've looked at bias and error mitigation. So we're going to include all of these things in our search for the diagnosis of lateral elbow pain. So with the extra tools, we can start looking at lateral elbow pain again and go a little bit further with it. So we have non-traumatic lateral elbow pain. Let's put it up here. And you would naturally use hypothetic abduction. There's a 90% chance there's going to be tennis elbow. So this is our first hypothesis, common extensor tendinopathy. To be perfectly technical about it, rather than a specific tendinosis, we'll start with tendinopathy and we'll prove on from that. So first test could either be pain on gripping, or you can go straight into palpation of the tendon, doesn't really matter. But we say if they've got pain on gripping and they say no, then we have to move on to the second selection here, H2. If the answer to that is yes, it is tendon, then we then move on to palpate the tendon. And again, if that is negative, then we go back to forming a new hypothesis. If though the tendon is tender, then we can look at positive isometric wrist extension testing. And if that is negative, then we have to go back to H2 again. We'll come back there in a second. But if that answer to that is yes, the isometric wrist extension is positive, we've got a pretty certain idea that this is at least provisionally common extensor tendinopathy as far as the provisional diagnosis is concerned. So now we need to subtype it. Is it tendinitis or tendinosis? We're going to look at that in more detail because I've got more information for you that I haven't given you yet. But assuming that it is tendinitis or tendinosis, then we can move on to a diagnosis. What we haven't done is this bit here, which is to check for bias and error. So let's move on to that. Okay, let's look at our first sticky point. We'll say that H1 fails, either because they had no pain on gripping, or because the tendon wasn't tender, or because isometric wrist extension was negative. So at this point, H1 fails. What we're going to say is they had pain on gripping and the isometric test is positive, but the tendon wasn't tender. So we now have to move to the second selection. So we can say that we can do it one of two ways. We can continue on with hypothetic abduction based on this information here. And that would generate an essential illness script. And we're going to say that it's going to generate one for biomechanical dysfunction of the elbow. Now, what we're seeing in the essential illness script is that the quadrant will be positive in a specific pattern. I'm not going to worry about what it is at the moment, but it will be different from the arthritic pattern of the quadrant. They would have a history of episodic moderate pain, there'll be no obligate functional loss, and the biomechanical exam will be positive. If all that works out, you have H2. If it fails, say the quadrant test is negative in this case, then you have to generate H3 and you repeat the process. Or the other way to select H2 is through exclusionary differential diagnosis. You could do it through inclusionary, but it takes a long time where you're trying to prove each one rather than trying to disprove or each one to eliminate it. It's a lot quicker and easier to disprove a thing than prove it. So these would be how differentials, biomechanical dysfunction, arthritis, arthrosis, lateral collateral ligament degenerative tear or an attenuation, a strain, or its referred pain. And for these, any of these to be eliminated, you would have to have negative quadrant testing in that particular pattern for the biomechanical dysfunction, negative quadrant testing for the arthritis-arthrosis pattern. The lateral collateral ligament is negative, and if all tests are negative, then it's likely to be referred, and there's your hypothesis 2 that you will then check with hypothetic abduction, which is positive vetting. So now you're going to try and prove the ones that you couldn't eliminate. Now I've taken the covers off and we can look at the bits that were missing before. Again, though, we've gone through this business, hypothetic abduction to H1, and we looked at what happened when we had to select H2, and we did that with the exclusionary differential diagnosis to generate H2, and then we went through the same process again. But now let's look at what happens if all of this pans out and we now have a provisional diagnosis of common extensor tendinopathy. We subtype it into tendinosis or tendinitis, depending on the patient's symptoms and signs. Now we go through bias and error mitigation. Now, if we do this and the results are acceptable, there are either no errors as far as we can see or no bias as far as we can see, or if they're at an acceptable level, then we have our working diagnosis from which we can generate a treatment plan, prognosis, etc. If these are unacceptable, now you've got to review the entire exam and revise the diagnosis and or get a second opinion. You may not be able to do this, but if you can't figure out what the bias here is, then the bias is hiding from you and you may need somebody else to tell you exactly what's happening. So this is with a bit more into it. The next slide will complete it and fill in the details. Okay, so now let's look at the whole thing with all of the tools available to us. I've put boxes around these because it does get more complex. So again, lateral elbow pain, hypothetic abduction, our H1, which is tendinopathy. And let's go through this. We looked at selection again, and you could either select this from exclusionary differential diagnosis or with iterative hypothetic abduction. Either or will work for you. But you do have to go through, if you're going to go through H1 again, you're going to have to generate this in some form or another. So we've made a provisional diagnosis of tendinopathy. Now we're subtyping, and this would indicate whether it's a tendinitis or a tendinosis. Severe pain, I mean severe pain. This isn't you pressing your thumb in trying to figure out if it's tender or not. This is you rubbing your finger over the top of their skin and them screaming at you. The pain is severe. It's severe enough that it causes obligate functional loss. They can't not just grip strongly, they can't grip. There's prolonged aching after they do try to use it. And there's painful weakness on isometric wrist extension. So if any of these are present, or if the majority of them are present, then you're probably looking at tendinitis. This is not one you want to use frictions on, eccentric contractions and so on, absolutely not. You want to get the inflammation reduced. If these are not factors, then your diagnosis is tendinosis, where you can now go to town and beat the hell out of it. Anyway, either way you've done it, you can now add it into bias and error mitigation via exclusionary differential diagnosis and repeating the answers back to the patient to avoid confirmation bias. If they're unacceptable, you have to review the exam and look at a second opinion. If they're acceptable, the levels of bias and error are acceptable as far as you can see. You now have you can now produce the treatment and the prognosis. And if you get a prognosis match, then you can start looking for etiology. If not, then you've made a mistake somewhere, and it may be in the treatment, it may be in the treatment plan itself or in the diagnosis, but you're going to have to review the entire process or get a second opinion. You've invested time now in this patient, and the patient's invested time in you. So don't ignore the failure of the prognosis match. Okay, so that's the process. It isn't terribly complicated. It's things you're probably doing anyway, but now you know why you're doing them, and you should also be looking at doing this consciously. This is a really simple problem. You start looking at more complex problems with multiple plausible differential diagnoses. This is a system you're going to have to use until you can develop pattern recognition. And this will help you develop pattern recognition faster than not knowing what the process actually is.